Assalamualaikum and hello. We are from Group 2 are going to present about air quality monitoring system and solution. In this simulation system, we have carbon monoxide input indicator A and indicator B to indicate the carbon monoxide. We also have carbon monoxide sensor at area A and area B to detect the carbon monoxide. We also have the carbon monoxide meter at point A and point B to monitor the carbon monoxide. We also have fan A and fan B to be as a ventilation at area A and area B. We also have auto ventilation switch for area A and area B to operate the system automatically. Thank you.
Okay, next for the process, as we increase the carbon monoxide at indicator A, we can monitor that the carbon monoxide value at meter A, when it comes to a certain point, which is 50 ppm, the indicator will turn red. The auto ventilation switch is pressed and operated the ventilation fan when it's reached 50 ppm and above. This ventilation system will operate only when the switch is turned on. If not, this system will be only for carbon monoxide monitoring system only. Thank you.
Okay, next for the advantage of carbon monoxide ventilation system. So the first one, it can alert people when carbon monoxide is present and at its most lethal. And the second one is to protect employees and the public and also save energy in the building. That is all from us. Next, we will continue on the next part.
Assalamualaikum. Okay, today issues is a water leakage problem due to high pressure of water flowing through the pipe in a building. So as you can see, our main tank is approximately 200 liter, and we set the scale of the ratio was one level is equal to 3.785 liter. So for the PSI pressure, again based on our research, we set that every liter is equal to 1.42 psi. For the mitigation process, we place a water pressure regulator in between pressure sensor at A and pressure sensor at point B. We use water sensor and place them at a separate point before the water flow through the water pressure regulator and after it passed through the pressure regulator. The meter at point A, as you can see on the right side, indicate the reading of the sensor at point A, while the meter at point B indicate the sensor, the pressure sensor for the point B. So for the LED, when the LED turns right, it means the water pressure is more or equal to 80 psi, while when it turns green, it means that it less than 80 psi. So thank you so much.
Firstly, we set the main tank at full capacity, approximately around 200 liter, and the pressure reading at both sensors before the water pressure regulator is turned on indicates that it is 285.291 psi, and the pressure alert LED at both meters turn red color. Based on our research, the optimal pressure of water that flows through a pipe is between 30 psi to 80 psi. Hence, it shows that the pressure in this pipe is very high compared to the optimal level. Therefore, for mitigation purpose, we place a water pressure regulator to regulate the pressure if the water is more or equal than 80 psi. We activate the water pressure regulator switch and see the differences as we compare the readings at sensor at point A and at point B. Point A is before water flow through the pressure regulator, and at point B is after the water flow through the pressure regulator. Now let's compare. The meter at point B automatically readjusts to below 80 psi when the initial pressure seems to exceed the limit level of 80 psi because the water already flow through the water pressure regulator. As we can see, again, as the pressure approaches 80 psi, at pressure point B, it automatically reduce below 80 as it flows through the pressure regulator.